Welcome to Module 6 of the DevOps Foundation course. We're going to talk about automation and architecting DevOps toolchains. This is just a terms, some popular terms associated with technology, tools, and automation. Absolutely not an exhaustive list. I refer you to the glossary that comes with the course for a more complete list. So if you don't know what an artifact is, it's an element of a software development project. So it can be documentation, test plans, images from builds, data files, executable modules. Basically, the output of any one of the stages in a pipeline could be considered an artifact. Some of those artifacts are release candidates or approved release images or deployment images and things like that. So a lot of things can be called artifacts. APIs, hopefully application programming interface, especially important today with microservices. The idea of having a interface that's available to access other services that are service-oriented structures, could be microservices or other things. Microservices themselves is a software architecture structure where you have modules of service packages, small modules that can interact through those APIs and be updated without affecting the entire system. That's usually known as loose coupling. That's a goal. It's still needs to be verified each time, but fundamentally it's a goal to have loose coupling because that allows you to reduce the amount of dependency management you have to do. OS virtualization is the idea of splitting a server into multiple partitions called containers or virtual environments in order to prevent applications from interfering with each other. Containers is a way of packaging software into lightweight, standalone executable packages, including everything needed to run it, which includes the code, runtime system tools, libraries, settings for development, for shipment and deployment. Open source is the software that's distributed with its source code so that the end user, organization, and vendors can modify it to their own purposes if they need to. And machine learning is the idea of using data analysis, using algorithms that learn from data. So I don't know, this is a very short list of terms, but some of the ones that are used in this module and throughout the course. Cloud containers and microservices, there's a couple of high-level charts here. One thing that has been proven through the different studies, through the State of DevOps reports, is the highest DevOps performers were much more likely, in fact, 4 times more likely to have met all essential cloud characteristics than low performers. In other words, the high performers are leveraging cloud resources. So cloud computing, as you probably know, is the practice of using servers remotely hosted on the internet, hosting applications rather than local services in private data centers. And the idea of having large monolithic applications, the best practice is to transform them into more modular architectures with containers containing microservices, usually one microservice per container to make things more flexible. Containers are really supported with a number of tools. Docker is the most popular tool for containerizing software. It make containerization easier to create, deploy, and run applications. Containers allow the developer to package an application with all of the parts it needs, libraries and other dependencies, and ship it as just one package without everything else that has to go with it. So it's a pretty lightweight way of deploying applications. Kubernetes is a tool that goes well with containers. It's actually the kind of the de facto standard. It's certainly not the only tool for managing containerized applications and orchestrating containers across multiple hosts, providing basic mechanisms for deployment, maintenance, and scaling applications. So Docker and Kubernetes often go hand in hand. AI and machine learning basically gives computers the ability to learn with data without being explicitly programmed. Organizations collect more and more data than ever these days. All these different tools generate a lot of data for all these different pipelines. It's hard to fully extract the value from that data without some algorithms or some tools like machine learning. So the data science is a discipline that helps people, specialists that figure out how to do that. AI and machine learning enables predictive analytics primarily, so that you can look at data and get inferences from the data, find trends, correlations, things that are hard for the humans to do manually, at least normal humans. It augments the human contribution, so humans can steer the analysis overall and leverage these tools. That boosts productivity and automates feedback loops. It's basically the idea of data analysis using algorithms to learn from the data. So there's some other terms. Deep learning is looking deep into the data using machine learning to get inferences, and artificial intelligence can make decisions based on the results of machine learning. And then people can use that. All right, DevOps automation practices involve what's called a tool chain, where you have typically a platform and plugging into that platform are many individual tools with specific functions. The tool chain philosophy involves using an integrated set of complementary task-specific tools, for example, build tools, testing tools, containerization tool, a lot of different types of tools that are needed across the tool chain to automate the entire end-to-end delivery and deployment processes. So the tool chain itself is comprised of multiple tools, often with multiple vendors and types of tools. It's not really a single vendor solution. It's a chain of tools that's designed to be and built to be integrated together through automation. Those are shared across the team, so people can access the tool chain in a self-service mode, preferably. And architecting software is important so that it can enable test automation and monitoring. Things like APIs are important, plugins and so on, to make it easier to automate. Supporting the infrastructure as code is a key part of tool chains to make them more efficient by having ephemeral, programmable as a service access to infrastructure aspects. And experimentation is also a lot easier if you have automation. You can change configurations and try different tools quickly if all you have to do is change some automation scripts. Also, it avoids tools that enforce silos, in the sense that you can switch out individual tools depending on any new versions and things like that. So you don't have just one group using certain tools necessarily. You can evolve the tool chain to satisfy more functions across the whole value stream. Try to get some commonality, sharing data and tools and scripts. Communication is also something that needs to be automated. Platforms can facilitate and expedite communication and collaboration across all the different team players, Dev and Ops, for example, QA, security, for example, issuing alerts and alarms through communication platforms, improving response by serving up data in real time on dashboards, provide at-a-glance status updates, things like Kanban boards, improving workflow through ChatOps, for example, automating workflows, improving information flow through workflow and project management tools, enabling virtual collaboration, things like document sharing, enabling cross-functional, cross-skilling and job sharing through things like wiki pages and center of collective practices, things like ITSM tools, social sharing tools, social media tools, backlog sharing, and a lot of different tools can help with communication as well, not just the the builds and the testing.